Okay, this is part 2 of Unit 5E, looking at correlation and causality. So in these next couple of questions we have here, we want to determine whether each statement makes sense or does not make sense and explain our reasoning. So on number 7 here we have, there's a strong negative correlation between the price of tickets and the number of tickets sold. So this would suggest that if we want to sell a lot of tickets, we should lower the price. That definitely makes sense because as we lower the ticket price, so as ticket prices go down, then that's going to lead to, hopefully, in theory, a higher number of sales. So as you lower that ticket price, more people are going to be inclined to purchase those tickets, assuming it's an event that they want to attend, but we'll assume it is an event that a lot of people want to attend. So as the ticket price goes down, the sale prices go up, so they have that kind of reverse characteristic. Lower the ticket price, higher the amount of sales, and vice versa. The higher the ticket price, less the sales most likely. And so in this case, that would be a negative correlation because as one variable decreases, the other increases, or vice versa. Okay, number 10, I found a nearly perfect correlation, negative correlation between variable C and variable D. Therefore, I was able to conclude that an increase in variable C causes a decrease in variable D. And this one is not going to make sense, so it does not make sense because, remember, correlation does not imply causation. Causation requires a lot of work, a lot of study. So just because two are even nearly perfectly correlated, there could be some underlying commonality amongst the two, but doesn't necessarily mean there's a causation. So let's look at those. Okay, next we want to interpret our scatter plots. So we're going to state whether or not each has strong or positive correlation, negative correlation, or no correlation. Then if it's positive or negative, is it strong or weak? And then we'll discuss any conclusions. So this first one, if we look at our dots here, if we were trying, it's almost like it tries to start to get a nice correlation, but then all of a sudden we have like these points starting to come down, and it really just kind of blows everything up because those fall way out of the pattern here when we're looking at unemployment percent and voter turnout percent from 1964 to 2016. So in this one, there's no correlation that jumps out because they're just kind of scattered all over the place, especially there at the end. And so we would just say no correlation on that. And so then there's not a lot to summarize in our conclusions other than they're just kind of all over the place there. Number 16, this one definitely looks to have a negative correlation. It appears to be very strong. So when we look at the number of farms compared to the average size of the farms, as the number of farms increases, the size of farms are decreasing. So there's definitely, and it's a negative correlation. So we say this is definitely a strong negative correlation because of how clustered together they are in that downward trend. And again, it's just, as the number of farms are increasing, their average size are getting smaller. That could be due to restraints in land. People could be splitting their farms, selling off a part of their farms to someone else. There could be all sorts of variables in here. So let's look at that one. Excuse me. So next we're going to be looking at types of correlation. So for each of these variables, we are first going to state the units that might be used to measure each variable. Then state whether or not we believe that the two variables are correlated. If we believe they're correlated, we're going to state whether it's positive or negative and why. So when we're looking at cities, we're looking at their latitude and their average high temperature in June. So when we're looking at latitude, okay, that's just going to be the degrees of latitude moving north and south. So that brings in a little bit of your geography there. We're looking at temperature. That's going to be degrees Fahrenheit or degrees Celsius, depending upon what country you're looking in. Outside the United States, most will use degrees Celsius. And so, do we believe there's a correlation? Well, there is a pretty strong correlation that the further away you get from the equator, so the further north or the further south you get, or the more you increase that latitude, the colder you tend to get. So, I mean, it can vary, based upon whether you're in the mountains or you're down in a low desert. But the tendency is the further away from the equator, so as you increase that latitude, the temperature decreases. And so in this one, there's actually a pretty strong negative correlation. And again, that's because as one increases, the other decreases. Okay, the next one, 21, for the 50 states. The year the state that joined the union, so that's one variable, and the land area of the state. So the variable that we're looking at for the states is the year they joined the union. Land area, square miles is going to probably be the most appropriate. You wouldn't want to go square footage or acres or anything like that. That would just be huge numbers. So we'll go square miles for our land area. And this one's a little bit harder to really pinpoint, because some of those first states that were taken on, you have some small states, Delaware, Connecticut, Vermont, and then Virginia, which is a little bit bigger. So some of those early states, though, they're pretty small. Some of the latter states that you take on, we get into, Alaska was one of the biggest, is as far as area wise, it is the biggest state. It was the second to last to come into the Union. And a lot that came in afterwards as the country moved west, they tended to have a little bit bigger area in square miles. But it isn't the case all the time. But there is a little bit of positive correlation there when you look up this data. A lot of the Midwest and West are just bigger, and those states were added later. So they have more square mileage. So as the years from when the state joined the unions, those increase, the square miles tend to increase, but it's not super strong, but it does exist there. Okay, number 26 is what we're looking at. So we're given a bunch of data over here in 26, and we need to make a scatter plot first. So when you need to make a scatter plot, Microsoft Excel or some kind of program like that is going to be very helpful for you. In your class, you're going to actually, when you're working in my math lab, it's going to give you a series of graphs for you to choose from. But if you can create these in Excel, it'll really help out. So when we make it, here's the scatter plot that I was able to generate in Excel. And so there's our scatter plot. We're looking at per capita income and the percentage of population below poverty level. So we want to state whether two variables appear to be correlated. Okay, in this one, if we were trying to draw a line of best fit, there doesn't appear to be any obvious negative. There doesn't appear to be any obvious positive here. Kind of have this random scattering here, so there doesn't appear to be any correlation. If there is, it's very weak. So we'll call this negative or no correlation. And And some of the reasons why, the per capita personal income and the percentage of population below poverty level may not be correlated here. One of the reasons is, each state has, a different population density. So if you compare the density of Utah, to New Hampshire, or to West Virginia, or something like that. I mean, we have very different population density. Some have a lot more people crammed into a small area, others do not. I mean, if you look at Montana, you compare that to Illinois, you'll find quite a bit of difference there. So population density could be one factor in there as to why they're not a lot of good correlation that we see. Another one is, laws by state. Some state laws and tax rates and other things are very different than others. Some have a higher minimum wage than others do, and so if you have a higher minimum wage, that generally pushes up that that personal income. You have cost of living, so there's a bunch of different variables that vary by state, and so it's really hard to draw any direct correlation between those two. Okay, the next one, we're looking at a table that gives mortality rate or literacy rates and infant mortality rates per 1,000 births for 10 different countries. Okay, I've drawn the scatter plots on the right hand side, and we see this huge cluster right here, dealing with these countries that have very high literacy rates. So there's our scatter plot that we're looking at, and this definitely looks like a strong negative correlation. As that literacy increases, the mortality rate decreases. It's going to follow this line. We have, one outlier right here that kind of throws it off, and it's Burundi. I don't know if I pronounced that correctly, but so that's kind of an outlier in our data. But other than that, it does look to appear to be very strong correlation. And the higher the literacy rates that a country has, the more educated, the more affluent the people are. More studying has gone into how to take care of infants. A lot of these tend to have better birthing facilities, more educated physicians and specialists, and so that would probably be a lot of reasoning behind that the correlation that we see there. Let me just go ahead and check my time here. Okay, we'll pause and we'll finish in our next video.